Hi everybody, let's take a look at section 6.2, which is where we're going to get into the normal distribution. This is a really important lesson, and we're going to take our time with this, spend a few days on it. The normal distribution we're going to use a lot in the rest of the course, because the normal distribution just has a lot of applications that we'll see as we go through the rest of the semester. So really make sure your phones are put away and take your time with the notes here, really process and make sure you understand all the symbols and what we're talking about. So first of all, the normal distribution, what is it? It's a special type of distribution, and it's a continuous variable distribution. So when we look at it, it's going to be a graph like we talked about in the last section. It's a continuous variable, and it's got three distinguishing features. The graph itself. First of all, they're always symmetric. That's important. So it's a symmetric distribution, just like we talked about back in chapter 3. It always has a single peak at the center, and it follows what you may call a bell-shaped curve. So I got a couple of examples right here of two different versions of normal distributions. Every normal distribution has a mean and a standard deviation associated with it that we need to be familiar with. The mean of the distribution, we use the symbol mu, that's the Greek letter for mu. The standard deviation, we use the symbol sigma, the lowercase letter sigma. And we've seen those before. I know we did them earlier in the course a little bit. They came up once in a while, but now we're going to use them again when we talk about normal distribution. Sometimes I'll use this notation where I use a capital N and then this parentheses and then a number, comma, another number. The first number is always the mean. The second number is always the standard deviation. So let's look at a quick picture here. We've got two different graphs. Notice that there's one in red, one in blue. They both have the same center, which is where the mean is, because it's a symmetric distribution, so the mean appears right in the center. Notice that both of these, it looks to me like the mean would be at 0. So the mu for both of these is at 0. And then it says approximate the standard deviation for each one. So it looks to me like the standard deviations are different. Notice that the one in red is much narrower, much more clustered around the center. The one in blue has a larger spread, more spread out, just like we talked about earlier in the course. Horizontal spread is what the standard deviation tells you. So the one in red, let's see, it looks to me like it's got a standard deviation. If this is at 2, this would be at 1, and this would be at 3. So it looks to me like the standard deviation for the one in red would be at 1. The one in blue, notice that it goes all the way out to 6 before it hits that third standard deviation. So that means that the standard deviation for that one would be at 2. If you're a little unclear on where I'm getting these numbers from, do not worry about it. That's not the important thing right now. Okay, we'll work on that part later. What I want you to pay attention to is the fact that the one in red is more compact and has a smaller spread. Therefore, it has a smaller standard deviation. Whereas the one in blue has got a larger spread. It's a flatter graph. It's more spread out, so it has a larger standard deviation. That's all I want you to care about right now. So don't worry about where I'm actually getting these numbers from at this time. Now, what about the total area? Remember we said in the last section, the total area under a continuous distribution has to always be what? And that would be 1. So whether you're looking at the one in red, this total area, or the one in blue, all of this, the total area is going to be 1. Now in example 2, notice that the spread for these is going to be the same. They both have the same spread, but the mean is different. For women, it looks like we're looking at height. So for women, the mean would be, and I'm kind of eyeballing it here, but I would say that maybe it's at, I don't know, maybe 64. And then for men, let's see, it looks to me like it's maybe, I don't know, maybe 70. Now, the standard deviation for both of these, I think, is about the same. Standard deviation is a little bit trickier to calculate just kind of by eyeballing it. I don't want to spend too much time on this, and I don't want you to get hung up on where I'm getting these numbers from. But I'm going to say I think the standard deviation for both of these is maybe about 2, 2.5, something along those lines. What I want you to pay attention to, though, is the fact that the spread for both of these is the same, that the shape of the graph, the spread horizontally is about the same, but the means are different. Now, what is the total area under each curve? Of course, that's going to be 1 for women and for men, because that's the total area when you have a continuous distribution. Now, let's revisit the empirical rule. We talked about the empirical rule back in chapter 3, and I want to just remind you again what that rule tells us. It told us that if we have a symmetric distribution, 68% of the data is going to fall within 1 standard deviation of the mean. 95% of the data is going to fall within 2 standard deviations of the mean. And 99.7, or really 100%, will fall within 3 standard deviations of the mean. And here's a quick picture of what this involves. And we're going to get a little bit more detailed here. Remember, I think earlier in the course we talked about breaking these down into the individual subsections. So let me remind you what those were. Remember, if this interval covers 68% of the data, each half is going to be 34% because of symmetry. And then remember that if 95% covers all the way out to 2 standard deviations, if we take 95 and cut out that middle 68, that leaves us with 27 remaining for this section and this section. So if we divide that in half, we got 13.5 for each of these little subsections. And then we have 5% remaining for the 2 tails. So if we cut that in half, we got 2.5%. And we'll review this again in class, but I think it's helpful to have a picture of all of these subsections somewhere in your notes that you can refer to when you're working with the normal distribution. So look at example 3. The chest measurements of 18-year-old male footballers is normally distributed with a mean of 95 and a standard deviation of 8. So mu is 95 and sigma is 8. Can we calculate these values using the empirical rule? Always draw a picture when you're working with these. So I'm going to just come up here real quick and I'm going to draw a little picture. And I'm going to put 95 in the middle. And we're assuming, by the way, oh no, they told us, I'm sorry, they did tell us that the distribution was normal. Okay, so if they don't tell us that, I'm assuming it, but they did tell us, so that's useful. So if sigma is 8, 1 standard deviation below the mean would put me at 87. 1 standard deviation above the mean would put me at 103. So that actually answers part A. Between 87 and 103, that would be within 1 standard deviation of the mean. So that would be 68%. The second part, 103 to 111, so let me go up 1 more standard deviation. If sigma is 8, 1 more standard deviation up puts me at 111. So they're asking then, if I go from 103 to 111, they're asking for this part right in here. And so go back to your graph, that would be the 13.5%. And so remember this, the rules with the empirical rule. Like I said, keep this picture somewhere in your notes where you can find it again, because we're going to use this quite a bit. Last little thing I want to talk about is the standard normal distribution. And again, I think we did this a little bit earlier in the course when we talked about z-scores. But remember that a standard normal distribution is a special normal distribution where the mean is scaled to be 0 and the standard deviation is 1. Total area under the curve, of course, is still 1, just like always. So when we talk about z-scores, remember that that follows the standard normal distribution. The mean would be 0 right here, and if you have a z-score that is positive, that means you're above the mean. If you have a z-score that's negative, that means you are below the mean. And we'll practice z-scores a bit more in class, so bring this with you. Be sure you're in class tomorrow. This is an important section to practice, and I'll see you then.